using these multiplication models and connecting our operations to the meaning of the operations will help us to become more fluent in math, and then also will help us to connect different facts that we know to each other, so that, again, it'll increase our fluency, but it'll also help us in times when we get stuck, and if we maybe don't remember or have never actually learned a certain fact. So here I have an example where I have an array of 6 times 7, and you can see I set it up three times there. That's because I'm going to do this in 3 different ways. So this is 6 boxes wide by 7 boxes tall, and you may remember from your multiplication facts what 6 times 7 is, or you may not. I'm not going to reveal the answer. The answer will be revealed, but we're going to look at different ways to calculate this based on relating it to other multiplication facts that we maybe do know better today or better in general. So again, this is 6 groups of 7 if you look in the columns, or if you look in the rows, it is 7 groups of 6. So the first way I'm going to look at this is I'm actually going to think of it as 7 groups, sorry. The first way I'm going to do this is to think about it as 6 groups of 7. And so maybe I remember that 5 times 7 is 35. And so I can kind of go, well, I know this much is 35. And so all I have to do is then add one more group of 7. I needed my rectangle on there. So what we're really doing is 6 times 7 is first we do 5 groups of 7, and then we add another 1 group of 7. Okay? So that may or may not resonate with how you see the calculations. And sometimes, it's worth mentioning that, like, the things that resonate with you might be different today than they are tomorrow. Like, sometimes when I encounter a calculation, one day I will approach it very differently than I will, a week from then. So another way that we might think about this is, well, I really connect to 5 groups of 6 first. So I say, well, I know that 5 groups of 6, let me label these again. This is 6 times 7. And maybe I know that 5 groups of 6 is 30. Darn technology. So I know that 5 groups of 6 is 30. No. 5 times 6 is 30. And what does that leave over? That leaves me with 2 more groups of 6. Two more groups of 6 is 12. So what I'm doing is 6 times 7. Let's get a more visible color here. 6 times 7 gives me I have 5. I'm thinking about this as 7 groups of 6. So 5 groups of 6, and then another 2 groups of 6. And I guess I didn't actually finish this calculation in the first one. I'll go back and do it. But here, that 5 groups of 6 is 30, and the 2 groups of 6 is 12. And so 6 times 7 would be 42. Looking back at this other one, we had 6 times 7 broken it up into 5 groups of 7 and then 1 more group of 7. that 5 groups of 7 is 35, and the one more group of 7 is 7, and 35 plus 7 is 42. Okay, so another way that we might do this is maybe we go, well, I know that 6 is 2 3s, so what if we just divide this down the middle and say I have 2 groups of 3 times 7. So I have 3 times 7 and another 3 times 7. And so I'm seeing this, and 3 times 7 is 21. So I can see 6 times 7 is, I first do 3 times 7, and then I multiply that by 2. So this is 21 times 2, which is 42. So these are 3 examples, and I urge you to see if you can come up with any more examples of how to do 6 times 7. So these are all operations that I did in an array or a grid, okay? And I'm going to look at these same calculations done in the number line. So you might think about this ahead of time. How would you actually represent these in the number line? Okay, so I'm going to scroll down here. I encourage you to actually pause the video and think about how would you represent these same 3 calculations on the number line. And rather than actually go through them and draw them piece by piece, I am going to just go ahead and do the reveal. Except somehow it disappeared. Apparently, I erased it before starting this video, so I will do it again. So the first one was 6 times 7. Well, I know what 5 times 7 is, so I do 5 groups of 7 first, starting from 0. So there's my first 7, my second 7, my third 7, my fourth 7, and there. So 5 times 7 is 35, and then I do one more group of 7. Okay, and so we end up at 42. Oops. Now the other one was saying, well, I know what 5 times 6 is, so this is groups of 6. If I'm looking at 7 groups of 6, I know what 5 groups of 6 is, and I'm going to need to add 2 more 6s. So I'm going to look at this one and do 5 groups of 6. There's 1, 2, 3, 4, 5 groups of 6. So 5 groups of 6 is 30. And then I'm going to add 2 more groups of 6. 2 groups of 6 is 12. And I end up at 42. Interesting thing here is, in fact, if you get accustomed to the patterns of just like going on these groups of 6, then you don't necessarily have to know that you landed on 30 and that you added 12 more. You could just sort of count the... I'm going to back up on that. Disregard what I just said. Okay, and the last one was saying, well, if I'm looking at 6 groups of 7, that's like doubling 3 groups of 7. So I can see this as, here's my 1, 7, 2, oop, that's a 6, not a 7. 2, and 3 groups of 7, and then I look at this and say, three times 7 is 21, and so I just add another 21. Okay. So these are just examples of how to represent these calculations on these two models of multiplication. And I would encourage you to play with this a little bit. And I have an exercise for you, which is coming. Okay, so if you can, so this is all about using connections of different multiplication facts, and there's lots and lots of ways to look at how you do these, how you connect these multiplication facts. So here's an example for you to think about. How many different ways can you use to calculate 7 times 9?